Hi, this is Max Hampel, and I'm going to be doing problem number 38 from the Chapter 3 homework. So the problem is, a river flows due east at 1.5 meters per second. A boat crosses the river from the south shore to the north shore by maintaining a constant velocity of 10 meters per second due north relative to the water. So part A wants to know what is the velocity of the boat relative to the shore. So here I drew a triangle where this side is 1.5 meters per second, this side is 10 meters per second, and the hypotenuse is the velocity. So using the Pythagorean theorem, we get that the velocity is 10.11 meters per second. And then using tangent inverse, we can determine that this angle right here is 81.47 degrees. So that means the answer is that velocity is 10.11 meters per second, and that it's 81.47 degrees north of east. And so part B wants to know if the river is 300 meters wide, how far downstream has the boat moved by the time it reaches the north shore? So I kind of modified my picture. And so here is the south bank and the north bank, or shore. And I drew that it's 300 meters across. So if the boat is right here, it wants to know what the distance in x is from here to here. So this is what we're trying to find. And so I drew a chart here. And so we know that the velocity initial of x and y is 1.5 and 10 meters per second respectively. And since the acceleration is constant, we know the acceleration is constant, so it's 0. The velocity is constant, so the acceleration is 0. We know that the velocity final is also this number. So once again, the velocity is constant, so the acceleration is 0. And so using the formula distance x equals velocity initial times time plus 1/2 acceleration times squared, we can get that the time is 30 seconds. Oh, and this is 0 because the acceleration is 0, so that makes that entire part 0. And then using that number, we can determine that the distance covered by x is 45 meters. So the answer for this problem is that it'll move 45 meters downstream by the time that it reaches the north shore. So there you go.